Alrighty, so we talked about so far, did a lot of evaluating, right? Find f of 2, find f of -3, find f of all different kinds of numbers. Today, we're going to be evaluating again, but we're going to stick with one value for x. We are going to evaluate for f of 0. The reason that we're going to spend a whole lesson talking about evaluating for f of 0 is because evaluating for f of 0 tells us something really specific and generally something that we consider a key feature for our functions. What do you think it is? The y-intercept, right? Okay. So if I think about this in terms of a graph, right? F of 0 means we're looking at an x value of 0. So an x value of 0 would be right here. When I evaluate for f of 0, that means I am finding a point that is going to be on the y-axis. That's our y-intercept, okay? As we get into our graphing intensive unit, we'll talk about for different functions, properties of that particular function that we can use to help us identify the y-intercept. So we'll talk about polynomials. We've got a couple polynomials up here, and we've got a line up there. You guys hopefully remember from Algebra 1, ways that we can find the y-intercept of a line, ways that we can find the y-intercept of a quadratic function. Some of those, for lack of a better term, sort of shortcut ideas we can use based on the sort of properties of the function. How can we identify this feature quickly? If I don't remember that, or if I run into a function that I'm unfamiliar with, we can still always find the y-intercept of a function by evaluating f of 0, by plugging in 0 for x. So that's where I want to start for today. If we plug in 0 for x, we can find the y-intercept. So for our first function here, this is a quadratic function. We saw stuff like this in Algebra 1, 3x squared plus 5x minus 2. We're going to plug in 0 for x. Anywhere I see an x. And then as we're evaluating, make sure you follow order of operations. Exponent before we multiply. So this would be 3 times 0 plus 5 times 0 minus 2. The nice thing about having a polynomial in standard form, this quadratic function in standard form, is that everything that's got an x is just 0. And my y-intercept is that constant term. So you may remember from Algebra 1, we said when I've got a quadratic function in standard form, I can see the y-intercept at the end. That's because if we plug in 0 for x, right, anything that has an x is just 0. The only thing left is my constant term. A linear function is also a type of polynomial function that follows the same rules. Here, we've got what we called slope-intercept form back in Algebra 1, but same idea. If I plug in 0 for x, this part is 0, and our y-intercept is 10. Now, if you recognize that we have slope-intercept form, and that constant term at the end is going to be my y-intercept, excellent. You can pull your y-intercept from there, from things that you remember about that particular function. If you don't remember those properties of the particular function, then you can plug in 0 for x to find your y-intercept. Okay, so that's what we're going to practice for today. Questions for me so far? So evaluating just like last week, just like last time, but this time only evaluating for 0. For our next function, same idea. This is another quadratic, but not standard form this time. Remember to follow your order of operations. So in parentheses first, 0 minus 3 is -3. And then we square before we multiply. 9 times out of 10, when I see a problem in a problem like this, and I see an issue in work like this, it's that we didn't follow order of operations carefully. So just be mindful. So I would have -16 times 9 plus 300. So this would be -144. and a y-intercept then of 156. I'm going to skip this guy for now and just keep going down my first column. I have an absolute value function here for h of x. I'm going to look at this guy next. Same idea. So we did a couple of quadratic functions. We did a linear function. We're going to look at an absolute value function next. Exact same idea. So this would be 2 times the absolute value of 0 minus 7 minus 8. Inside my absolute value bars, remember, we treat them like parentheses. We treat them like a grouping symbol because I've got stuff to simplify within there. So this would be 2 times the absolute value of negative 7 minus 8. What's the absolute value of negative 7? 7. So I've got 2 times 7 minus 8. So that's 14 minus 8. That means my y-intercept here is 6. And then I'm going to skip and continue down this first column. We've got an exponential function now. Same idea. I'm going to do exactly the same thing. I'm going to plug 0 in for my variable. So I've got 1,000 times 1/4 to the 0 minus 1 power. I don't have anything to simplify inside my parentheses here. So the next thing I would want to look at is my exponent. That means I need to simplify my exponent so I can take 1/4 to the whatever power. So 0 minus 1 would be the negative first power. We talked about this briefly in our last couple of lessons, but remember that negative exponent is going to give me the reciprocal. So I would have 1,000 times 4 to the first, right? Reciprocal instead of 1/4. Now I've got 4 to the first. So that's just 1,000 times 4. My y-intercept would be 4,000. So if I've got a polynomial, like our first couple, if I've got an absolute value function, if I've got an exponential function, we've got some square root functions and some rational functions here, other types of polynomials, all of them, I can find the y-intercepts by evaluating f of 0, plugging in 0 for x. I would like you now to try the remaining problems on the front page. Okay, the remaining problems on this first page. Make sure you're careful with your order of operations. I would also strongly encourage you to get into the habit of writing down your work as you go. So I can walk around and see a lot of people writing their work out the same way that I did. Excellent. Okay. I want you to get in the habit of writing down your work so that when we get to a quiz or a test, we're already in that habit of showing me all of your work. If your final answer is incorrect, I want your work to determine personal credit. We're on the right track, and there was just like a whoops, you told me 2 times 3 is 5 instead of 6. That's not a big deal. We'll give you credit for having the right idea, for knowing what you were supposed to do. If I don't see your work, and I don't have anything to base that person in a habit of writing that. Okay, looks like we're just finishing up. So I want to go through what we should have gotten for each of these, and then I want you guys to tell me if we need to go through any of them, work through any of our problems here. So the y-intercept in the second column should be negative 12, 800, negative 8, 12, and then the only problem left in that first column, this rational function here, you should have gotten negative 1/10 or negative 0.1 if you're a decimal person. Any of these we would like to see worked out. You want me to go through it? Let's scoop this up. See if we can get all of that in one screen. There we go. Any of these you would like me to work through? You feel okay about these? The next thing we're going to talk about is something else we did in Algebra 1, so this should look familiar again. When I ask you to interpret a point, okay, from a function, interpret some values from a function, we're going to do that with y-intercepts specifically. So on the next page, I've given you a couple of functions here that all have a context. Okay, so we're going to find the y-intercept just like we did on the front page, but then we're going to explain what that y-intercept represents in the context of our function. So for number 1, a toy rocket is launched from a platform. The height of the rocket is given by the equation that we see there, where t represents the time in seconds after the launch. Those of you that had me in Algebra 1, I told you anytime that we are talking about a quadratic function, an x squared function, and we have a context, like 9 times out of 10, it's going to be some sort of projectile, right? We have a rocket, we have a firework, we have a ball that's being kicked or thrown or hit. Something is going up in the air and then coming back down. Projectiles galore when we talk about quadratics. And so we've got a projectile here, a little rocket that we're talking about. I want to go ahead and find the y-intercept, and then we'll interpret what the y-intercept is telling us in the context of our problem. So to find the y-intercept, that is exactly what we just worked on. I'm going to plug in 0 for my variable in my function here. So this would be negative 16 times 0 squared plus 56 times 0 plus 32. I'm plugging in 0 for my variable there, and then I'm going to simplify so we can see our y-intercept. Now 0 squared here is just 0, and negative 16 times 0 is 0, plus 0 plus 32. So our y-intercept is 32. Now for the interpret part. Remember, when I ask you to interpret something or explain something in the context of the problem, what I'm asking you for is essentially to assign the labels to the different parts of that point, right? So our y-intercept is 32 means we have the point 0, 32 on our graph. So I want to know, what does the 0 mean and what does the 32 mean? 0 what and 32 what? Anybody want to take a stab at this one? 0 is representing what? The what, sorry? The time, right? 0 seconds. Anytime we're looking at time as one of our variables and it's 0, it's okay to say at 0 seconds or initially or at the beginning. Any of those work. And then how about the 32? What's the 32 representing? I realize I didn't give you a unit label here, but it's representing the height, right? The height of our rocket. So we could say something like the initial, since we're at the beginning, the initial height of the rocket is 32. And I didn't specify, so you can choose your own adventure here if you want it to be 32 feet or 32 inches. or 32 meters. You could also say at 0 seconds, the rocket is at a height of 32. Number 2, same idea. Anna is ordering food from an online delivery service. Her total delivery fee is given by this equation here, where M is the number of miles away from the restaurant. So the delivery fee, the cost for this delivery, is equal to 3 plus 0.75 times how many miles away from the restaurant she is. So let's find our y-intercept. We're going to plug in 0 for our variable. 3 plus 0.75 times 0. Okay, this is the easy part of this problem. This guy is just 0. 3 plus 0 is just 3. So we know our y-intercept is 3. But what does it mean? What do we think this means? Well, remember, M is our miles. So we said we're 0 miles. So what would the 3 be then? Not time, but cost, right? Because we're calculating our delivery fee. Okay. Does that make sense though with costs? Okay. So this probably seems kind of weird if I were to explain this in like very literal terms. Like if you are 0 miles from the restaurant, the cost or the delivery fee is $3. That's probably a little like of an odd thing to say. I want you to think about some of the example problems we saw for our linear functions in Algebra 1, where we talked about like the cost of a taxi or a ride share. There's usually a charge per mile and then an initial fee or like a booking fee of some kind. Or we talked about like if you have maybe a plumber come to your house, there's usually a service fee and then a charge per hour. So this would be like our service fee. Okay, that's $3. It's sort of my initial charge, or I think I called it my base charge. The reservation charge or cost for delivery is $3. It's going to be at least $3 if you want your food delivered from this restaurant. And then our last one here, this one's a little more straightforward. The town's population is represented by this equation, where T is the number of years since 2020. So we want to find the y-intercept. We are going to plug in 0 for our variable. So 16,000 times 1.03 to the 0 power. What's anything to the 0 power? Anything to the 0 power is 1. Very good. So this part's 1. 16,000 times 1 is just 16,000. So we know our y-intercept is 16,000. What is this in the context of the problem? What is 16,000? The population when? Yeah, the population of the town is 16,000 in 2020. Our variable here represents how long it's been since 2020. We are counting from 2020. So if we plug in 0 here, that means 0 years since 2020. Well, that's just 2020. Very good. Okay, on the next page for me. Last thing for today. Every example that we've seen so far has had a y-intercept. Okay, that's because I picked examples for us to start with that had y-intercepts, functions that had y-intercepts. But that won't always be the case. We will see functions that do not have y-intercepts. So when we talk about functions that do not have y-intercepts, if I sketch a little graph here, that might be something like a square root function, where maybe that sort of terminal point, that end point, is in front of the y-axis. It could also look like we'll talk about rational functions later on that are sometimes sort of separated into different pieces, and those pieces may or may not cross or touch the y-axis. We could also be talking about a vertical line. That would not have a y-intercept if it's not on the y-axis. We'll see a few other types of functions. Logarithmic functions are another one that we'll talk about, related to exponential functions. We know exponential functions have that horizontal asymptote. Logarithmic functions are related to them. They have a vertical asymptote instead. So if that vertical asymptote happens to be on the y-axis or in front of the y-axis, then our logarithmic functions wouldn't have a y-intercept either. The two things that we are going to look out for when we are finding y-intercepts algebraically, it's easy to see on the graph that none of those I've sketched have a y-intercept. But algebraically, we're going to look for division by 0, and we're going to look for the square root of something negative. Remember, when we divide by 0, we have a special term for that. Does anybody remember what it is? Starts with a U. Undefined. So if we plug in 0 and we get something undefined, no y-intercept. And then square roots of negative numbers we saw a little bit last week. Remember, those are not real numbers. Later on in Algebra 2, we'll talk about specifically what are they if they're not real numbers. But since they're not real, we won't see them on our Cartesian coordinate plane. Okay. So let's look at a couple of examples. For our first example here, we're going to do the same thing that we did on the front page. We're going to plug in 0 for our variables. So 0, 0, 0, 0. So 0 squared is 0. 2 times 0 is 0. 17 times 0 is 0. So I have 0 plus 0 plus 8 on the top. That's just 8. On the bottom, 0 squared is 0. 3 times 0 is 0. Minus 0 is 0. So I have 0 on the bottom. That's undefined. Since I have something that is undefined, we say we have no y-intercept here. If you are plugging in 0 for your variable and you get something undefined, that means you do not have a y-intercept. Let's take a look at our next example. Same idea. I'm going to replace all my variables with 0. So on top, we would get 5. On bottom, we've got 0 times -3 times 1. If I didn't have that x in front, we'd be okay. We could find a y-intercept. But since I do, on the bottom, I've got 0 times -3 times 1. That would be 5 over 0, which is, again, undefined. So we have no y-intercept. We're going to try a couple more together. Our next problem, again, we're plugging in 0 for x. So these first 3 that we're looking at are all what we call rational functions. I've got some sort of polynomial on top and some sort of polynomial on the bottom. The first 2 we looked at, no y-intercept. Let's look at our third one. So this would be 0 minus 2 on top, which is -2. And then 0 minus 0 plus 7, -2 over 7. Can I have a y-intercept that's a fraction? Is that okay? I've got some yeses and some nos. Yeah, it's okay to have a y-intercept that's a fraction. Does it have to cross the y-axis at a nice value? No. Plenty of functions do not have a nice y-intercept, and that is okay. It would be a problem if I had an undefined y-intercept like what we saw in our first couple of examples where we had 0 on the bottom. That's an issue. Fraction, that's fine. So our y-intercepts here would be -2/7. And then our next problem, we've got a square root function here. Same idea. I'm going to plug in 0 for x. So 2 times 0 minus 10. This would be the square root of 0 minus 10, which would be the square root of -10. Square root of a negative. This is not a real number. So we have no y-intercept. I will not see my graph cross or touch the y-axis. No y-intercept there. I want you to try the last two here. So you guys try these two. Do these last two have y-intercepts? Yes. They both did. On the first one, when I plug in 0, I have 0 plus 18 on the top. And on the bottom, this is 0, this is 0, -18 on the bottom. So our y-intercept would be -1. And then for our last function, if I plug in 0, we have the square root of 9 plus 4. Do we know the square root of 9? Square root of 9 is 3. Yep. Even if this wasn't a nice value, as long as it's not negative, that's okay. This one does happen to come out to a nice number, and we get our y-intercept to be 7. Very good. Last thing for today. I would like you guys to write your own function that has a y-intercept of 8. It can be as complicated or as simple as you would like. And then I would like you to write me a function that does not have a y-intercept. Okay, try those last two. For the last one, you may not reuse the problem from above. Okay, I want you to try those last two. Do not put your notes away just yet. Again, as complicated or as easy as you want to make them. probably the simplest function you could have written for this first one would be y equals 8. That would just be a horizontal line through 8. You could have also done y equals maybe 2x plus 8, a linear function, or a quadratic, maybe x squared, we'll say plus 4x plus 8. Okay. You could have done something more complicated than any of those. That would have been fine too, as long as when you plug in 0 for x, you're left with 8. Our simplest functions, I think, that would not have a y-intercept would be maybe 1 over x, because if I plug in 0, that's undefined. I could have also done the square root of x minus anything, because when I plug in 0, that would be the square root of a negative. That would work too. Again, you could have done something more complicated if you wanted, but those would be some of our simpler examples. Okay. One last thing I want to make sure we talk about and point out here, little note up at the top. Linear, quadratic, any polynomial, linear functions and quadratic functions all fall in that umbrella. This would also be x cubed functions, x to the 4th functions. So any polynomial and exponential functions will always have a y-intercept because I can plug in whatever I want for x in those functions. The domain is all real numbers. Anything from negative infinity to positive infinity is fair game to plug in for x. That means it's okay to plug in 0 for x, and nothing weird happens. Nothing's undefined. Nothing's the square root of a negative. So for those types of functions, I should always expect to have a y-intercept. For some of our rational functions, which we'll talk more about, some of our square root functions, we may not always have a y-intercept, but for polynomials like linear and quadratic functions and exponential functions, we'll always have a y-intercept.